Okay, let's continue from where we were yesterday. So yesterday we looked at limits and we looked at binomial theorem. Okay, everybody okay with that? Okay, so now I'm on page 180 at the bottom. So we're looking at differentiation from first principles, right? Don't tell my mother about what happened yesterday.
You recording?
Yeah,
When you start recording?
about 20 minutes ago.
You were joking about things it's true.
Okay, so differentiation from first principles. So the gradient of a straight line, consider the following straight line. So you see they got two graphs there, right? They got two functions, you got y is equal to 2x, and on the other graph you got y is equal to minus 4 over 3x, right? The gradient, so remember a while back I told you for gradient it's equal to the change in y over the change in x. So for gradient of a straight line you would have said the change in y all over the change in x, which basically means y2 minus y1 all over x2 minus x1. Now the formula for a straight line, y is equal to mx plus c, gradient being m. So if I had a graph like this, and if the graph cuts it like that, right? If I take 2 points, say for example I take, this would be x1, this, okay, maybe I should do it the other way. Okay, x1, y1, right? And if I take another point, and let's say, yeah, right? That would be x, okay, let me try the other way. No, actually. So, if this is your axis, right? And if you have a graph that's being something like this. Is my phone? Okay, so this point here would be x1, y1, right? The coordinate would be x1 and y1. And if I take another point, x2, y2. Right? So I'll have another coordinate of x2, y2. So if I substitute it there, I'm able to work with the gradient. If you have a positive gradient, a positive value for m, your graph looks something like that. If you have a negative value for m, your graph will look something like that. Okay, so that's working on the gradient. So that's what they're showing you over there. They said the gradient at m1 is equal to change in y over change in x. Right? And then they showed you 4 over 2. So if you look at the graph on the left hand side, right? Can you see at the bottom you have change in x on the x-axis? Right? From 0 to that point it's 2. So the change in y, the change in x is going to be 2, right? And then if you look at the change in y on the right hand side going up, it's from 0 to 4. So it's 4 units, like, right? So from there it was 4 units, the change over there was 2 units. So they worked on the gradient, 4 over 2. You understand what I'm saying, right? Yeah. Okay. Then, if you look at the other graph, they basically did the same thing. So they were just basically showing you the gradient of a straight line. How you would have done it, you would have done it normally with y2 minus y1 over x2 minus x1. You take 2 points, right? Now, let's look at the gradient of a tangent to a curve. So, this is where first principle is going to come in, right? And part of what I'm saying here will be how you would derive the first principle formula. So, can I take this up? Yeah. This was just the intro. Oh yeah, take a picture. Should I just post it? Let me just stretch it. Okay, go on. Okay, now I'm going to the important thing, right? So, right, so they tell you A with coordinates, okay, so if they're looking at the diagram on the next page, right? The diagram on top of page 182. So you have a graph, this is your y-axis, function that looks something like that. So the function you have is y is equal to f of x. Right? That's the formula for the line that we showed you. Okay? So they tell you that a with coordinates x and y is equal to, so they have one value here. So this is your x coordinate. The corresponding y value would be f of x. Right? You're okay with that? Okay. Then they tell you is a point on a curve y is equal to f of x. B has been obtained with a small value of delta x being added to x. So whatever the x was, they added a small change. So basically, they moved like to another point, right? So this point here, let me try to do it for you, is x plus the change in x, and this portion here is the change in x. Yeah, we understand it? Okay, cool. Right? Delta x has been magnified for clarity, and then this corresponding point here would be f of x plus the change in x, right? And this portion here would be a what? Change in the y value. You all okay with that? Okay. Understand, right? Good. So, the gradients, so they're basically saying there's 2 points formed there. Okay, that's supposed to go through that, right? But if I draw a straight line through, if I draw a line through the 2 points, it forms a straight line. And the gradient of that straight line would be a change in y all over a change in x. Okay? So this here would have been y2 minus y1. So this would have been f of x plus delta x minus f of x, and then we can just call that a change in x, right? Because that is the difference, right? I'm trying to show it all in terms of x. So far you all with me, right? Okay. Right. Then they tell you that bring b closer to a. I'm on page 182, just below the diagram, right? Bring b closer to a. If b reaches a, the value of the change in x will move towards 0. Get it, right? So they're saying if I bring this was point A, this was point B. If I start moving this point closer to A, this delta x is going to move towards 0 because I'm making the line. So I'm pulling it from the right towards the left, right? And chord AB becomes a tangent to f of x at point A. Do you know what a tangent is?
Where this, if you got a circle, it just touches one point.
Yeah, so if you have a circle, this cuts the graph at a perpendicular axis, right? And that's normally what we would use when we work in our gradients, right? So they're saying that if you pull this closer, it's going to form a tangent to the curve. Right? My graph is not drawn so accurately, but that's what they say. Okay? So the formula will now become, if we start introducing limits of, if we introduce limits, the gradient of the tangent to f of x now becomes the limit as the change in x approaches 0 for that. And then remember we said delta y over delta x is equal to f of x plus delta x minus f of x all over delta x, right? So graphically delta x, generally delta x is replaced by h, and then the formula for the gradient of a tangent to a curve becomes, so you'll change the change in x to h. So the gradient would now be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Right? So far guys, you understand what I'm doing, right? Just showing you how we come to this formula.
We don't need to know this, huh?
Sometimes they do ask you but to derive the formula for first principles. So you'll draw this diagram with the same labeling. You'll show how you would work out the gradient, right? you will say delta x moves towards 0. Using limits, you get that, and then you get that. Sometimes they ask, because you say you must know how to derive first principles, right? But the above limit is also called your differential coefficient of a function of f of x with respect to x. This here is your first principles formula, right? If they ever ask you to solve a question using first principles, that's what you're going to be using.
Can you write it?
What? Right? It is also called the differential coefficient of a function. Right? So when I'm telling you between first principles, that's the formula I'm going to be using, right? And if they ask you to derive the formula for first principles, that's what you will do. Okay, so far you're all with me?
Yeah.
Okay, cool. Right? Then they tell you the differential coefficient was calculated using a limit. We can accept that the limit must exist. The limit represents the gradient of a tangent to a point on a curve, and the function must therefore be defined at a point. These conditions satisfy the definition for a continuous function. Okay, that's just theory, right? They give you 2 notes to make there. Well, not really important, but the differential coefficient represents the rate of change between 2 variables at a at a specific point. It indicates how y will change if x changes. Another point they tell you is that the differential coefficient also represents the gradient of a tangent to a curve at any point, and that formula there would be used to work out your gradient, right? Okay. At the top they tell you it is also used to calculate the differential coefficient and is indicated by f prime x. So sometimes you may see the symbol f prime x, and this is differential coefficient of a function. Okay? Right. It is also called differentiation from first principles. Okay? Are you all with me? Everybody's with me? Okay. That formula is the most important thing you need to remember with first principles. Okay? Sometimes they replace m and they use this term here, f prime x. So it's differential coefficient of a function. The function would be whatever you're substituting into that. Okay? That will be the differential or the derivative of whatever you're working with. And you're going to see it in examples. I know theory looks crazy at the start, but once you do examples, it all becomes easier, right? You all understand me? You're all on the same page?
Yes.
Okay. Yeah, I can take a picture. I'm going to do an example now, right? Now you're going to see how, remember when I said, when we used to write f of x and it's the function with respect to the independent variable? When we did graphs, right? So that's going to come into play now. You're going to see, well, that's come to play. We use binomial theorem, a few other things. A lot of the rules that we thought that term was unnecessary is going to be used now, right? Okay, so can I take this?
Yeah.
Okay. And please, see when he posts these pictures on the group, please go home and redo what I'm doing, because the first time you may just understand by what I'm saying, but if I had to give you to do it again, you won't know it, right? So if you go home and rewrite what I wrote on the board, you'll be able to understand it better because it's like you doing it for the second time, right? And that's how it gets stuck in your head. So, the example, right? They want you to calculate the gradient of a tangent y is equal to x squared at x equal to 3, right? So we're going to use first principles to work this out, right? Now remember with first principles, we have the function of x plus h plus, minus the function of x all over h, and it's the limit as h approaches 0. So we need to make this in terms of f of x plus h and f of x. Okay? How do we do that? What is your independent variable here? X, right? So x is the independent variable, because this here y will be dependent on the value of x. So remember, when we write in terms of functions, we'll say the function of the independent variable is equal to whatever equation we're given, right? X squared. You all with me? You all remember this from graphs, right? Right. The other term we have is f, the function of x plus h. And remember, this is the same thing like if I gave you all an equation and if I said f of 2. So what you would have done? Like if we had f of x equal to x squared, right? And if I said f of 2, what should I have done? You would have substituted 2 into the bracket and then you would have solved it, you would have got a number, right? Same thing over here. But now what we're substituting into the equation? X plus h. All with me?
Yes.
Right. This here is x plus h all squared. Okay? So let's expand this bracket, right? So this would be x plus h, x plus h. So when you multiply, that will be x squared plus 2xh plus h squared. All with me. Right? Now they want the gradient. Now we're going to use first principles. So gradient would be equal to the limits as h approaches 0 of f of x plus h minus f of x all over h. First principles formula. Right? This would be equal to the limits as h approaches 0, substitute now. So f of x plus h will be that. So it will be x squared plus 2xh plus h squared minus f of x, right? Which should be
X squared.
minus x squared all over h. Still with me? This and that will cancel. So now you're left with the limits as h approaches 0 of 2xh plus h squared of all over h. Now what happens if you substitute the limit value? You're going to end up with 0 over 0. And when we have limits in the form 0 over 0, what do? You factorize, right? So in this instance here, I'm going to pull out a common factor. What? Because I want to get rid of that h. So I'll pull out a common factor at the top. So this would now be limits as h approaches 0 of h into 2x plus h all over h. That and that will cancel. You're left with the limit as h approaches 0 of 2x plus h. Right? So now I can introduce the limit into it. So this would be 2x plus 0. So your gradient is equal to 2x. Right? They asked you for the gradient at x is equal to 3. So all you need to say is if x is equal to 3, your gradient will be equal to 2 times 3, which is, that's what you do. Is everybody okay?
Yeah.
Eh? Anybody confused about what I did? Not bad. Not bad, right? All I did was, this is what it was given. I wrote it in terms of f of x. How I wrote it in terms of f of x, this is the function of the independent variable. Our independent variable was x, right? So f of x is equal to x squared. Because I know I'm going to use first principles to work it out, I need to also write it in terms of f of x plus h. So all I did was I substituted x plus h for the value of x. It's exactly like how if I said f of 2, you would have substituted it into it and you would have got an answer. So I did that and I evaluated it. Now I use my formula for first principles. That's the formula for first principles. I just substituted. When I substituted, I saw that this and this would cancel. So I ended up with this. But now I can't introduce the limit into this because I'm going to end up with limits in the form of 0 over 0. So I pull out a factor that could get rid of the factors that's going to give me 0. Right? That and that would cancel. I'm left with this. So I took the limit, and because h approaches 0, wherever I have h, substitutes the value of 0. So I was left with this. So that's your gradient formula, 2x. And because they asked what is the gradient as 3, I substituted 3 for the value and I'm going to
I think we're gonna have to do it one step at a time on our own
yeah.
by doing examples of each one.
The only thing with the differentiation, you have to do examples. That's the only way you're going to get it. Right? But from what I did here, I don't expect you all to get it in the first 5 minutes I say it, because
It's not confusing.
it's not confusing, but when the more you'll do it, right, there's nothing to trick you all up there. Okay? Okay. Any questions about this? You would have done the symmetry.
Yes.
You do the symmetry.
We didn't do it.
The new one is the youngsters. No, this was OPE.
This is first differentiations from first principles, and a few of your short methods for differentiation was taught in metric.
Which
It was your calculus.
Which year was that? Wait, which calculus?
Calculus.
No,
I-
the other one we did.
Can I take this up? Tomorrow, guys, please make sure you're here because I'm going to be doing revision. So, you know how important revision is. Okay, so let's do another example, right? They want the differentiation of calculate the differentiation coefficient of, and then they give you y is equal to 3x squared plus 2x. Right? That's what they want. Now, how do we do it?
Okay. That's it. F of.
So you make it in terms of f of x first, because we know we're going to use first principles, right? So, what is your independent variable? X, right? So, when you're writing a function, you say the function of the independent variable is equal to that equation, right? Okay. Another thing we need to do is have the function of x plus h. So, wherever we see x in this equation, you'll substitute x plus h, right? So this would be 3 into x plus h all squared plus 2 into x plus h. So evaluate this, right? So this will be 3 into x squared plus 2xh plus h squared plus 2x plus h. This would be 2h. Sorry. This will be 3x squared plus 6xh plus 3h squared plus 2x plus 2h. Straightforward, right? No terms can join together over there, anything, so we'll leave it again. Right? Now we introduce first principles, right? They asked you for the differential coefficient. How does that symbol look?
That F. What?
F prime x, right? So it's f prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x all of h, all together, right? This will be limit as h approaches 0. So you substitute your values for f of x plus h. This is 3x squared plus 6h plus 3h squared plus 2x plus 2h, right? Minus that, right? So it's going to be minus 3x squared minus 2x. Okay? Do I need to show you how that is? It's fine, right? This will be minus. I'll show you.
Show. Yeah, just show it.
Okay, so remember this here is that. Right?
No, it's the whole thing.
That is that. That substitutes for that. Minus f of x is 3x squared plus 2x all over h. So all I did was I swapped f of x for its function, substituted that, swapped f of x for its function, substituted there. Okay? So this would be the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 3x squared minus 2x all over h. Right? What's going to happen now? 3x squared and negative 3x squared is going to cancel. 2x and negative 2x is going to cancel. So you're left with the limits as h approaches 0 of 6xh plus 3h squared plus 2h all over h. Now if I take the limit at this point, what's going to happen? I'm going to end up with the form of 0 over 0. So I'm going to factorize. What I'll do, I'll pull out a factor that causes me to get the zeros, right? And the factor is h. So this is the limit as h approaches 0, h into 6x plus 3h plus 2 h. Cancel, cancel. I'm left with the limit as h approaches 0 of 6x plus 3h plus 2. Right. Now I can introduce the limit as h approaches 0. So if I introduce it, it's going to be 6x plus 3 times 0 plus 2, which is equal to that is f prime x, or the differential coefficient, or the formula for the gradient of the tangent to the graph that you would have drawn for that at any point. Okay?
And then for the gradient, you go to the other one.
For the value of the gradient.
The value.
Yeah, you substitute any value for x. But these formulas are used for graphs, this differentiation and all that stuff. We'll see later on, you're going to learn how to work out the area of a graph, or the area, you know, like if you have from the axis, if you curve an inside portion, what is the area of it? You can use this, you can use the graphs to calculate turning points, you can use it to do intercepts with differentiations. Do you understand what I did here, guys? Anybody confused? Fine. Okay, you obviously need to go home and practice it, right? Good example. Okay. With that, I'm on page 184. Right? Right. Page 184. Just after that part where they got to 6x plus 2, they tell you that differential coefficients of expressions like x to the power 10 results in time-consuming calculations. Remember, x to the power 10, f of x would have been x to the power 10, right? And so I'm saying, when they said over here, differential coefficients of expressions like x to the power 10, the results in time-consuming calculations. Why? Because f of x would have been x to the power 10, right? F of x plus h would have been x plus h to the power 10. And then you're going to have to work out 10 brackets of x plus h, right? What would we use when we get something like that? Right, binomial theorem, which we did yesterday. So, a special method is also needed to deal with the square root of x, which is x to the power half. How are we going to get x plus h in that bracket? Right? So we need a method. If the binomial theorem is used to calculate the first 3 terms, the above mentioned type of problem can be easily solved. So I highlight first 3 terms. Highlight first 3 terms.
This is specific to this.
For first principles.
But
But if they ever ask you a question on its own for binomial theorem, they would use 4. But they'll tell you up to 4. So know the formula up to 3. You just need to know. But you'll see why it's 3 when I'm doing a calculation, right? So, they like sort of recapped over there on the binomial theorem, right? So you have your binomial theorem, the formula for it, right? And you see they only show up to 3 terms. Remember yesterday we did up until n into n minus 1, n minus 2 all over 3 factorial. Okay? So, they give you examples. Do I need to go over that binomial theorem again? Are we all okay with that?
Yeah, yes.
Right? It's a straightforward formula and you substitute, right? So now I'm going to do the example where they say calculate the gradient of the tangent in the bottom, right? Calculate the gradient of the tangent y is equal to square root of x at x equals to 4. Okay? That's what I'm doing. Okay? Yeah, can I take this up? You took a picture?
Yeah, I posted already. Shading the example right at the bottom.
Yeah. Bottom of page 184, complete that example, right? So the example is
Y is equal to x. Square root of x.
y is equal to the square root of x at
X equal to 4.
x equal to 4. They want the gradient of the tangent, right? So how would we do this? Now when we're working on the gradient, we're obviously going to use what? First principles, right? So to use first principles, we need to know f of x and we need to know f of x plus h, right? So your independent variable is x, agreed? So the function of the independent variable would be equal to, and I'm going to write this as x to the power half, okay? So this is x to the power half. Fine. Okay. I also need to have f of x plus h, and that would be x plus h to the power half. And how do I evaluate the bracket? Binomial theorem, right? Because I can't say x plus h times to the power half times x plus h to the power half, right? You have to use the binomial theorem. And your binomial theorem was, if you have because
I plus
Okay.
b to the power n or x plus
let's say x plus
x
h
plus h
to the power n is x to the power n plus n x to the power n minus 1
h
h plus
N times n minus 1
all over 2 factorial
x
n minus 2
h2
h2, right? And then so on and so on, right? Okay. In this instance here, your x is equal to x, your h is equal to h, and n is equal to half, right? For first principles, we only evaluate for the first 3 terms. You'll see why in the calculations, right? So using binomial theorem, we're going to end up with x to the power half plus half x to the power half minus 1 h plus half into half minus 1 all over 2 factorial x to the power half minus 2 h squared and so on, right? Keep on going. Okay, so let's simplify this. This would be x to the power half. This would be half x to the power negative half h. This would be what? Half minus, I think 1 over 8 that yesterday you, because that would have multiplied to negative 1 over 4. And then, I think it's negative 1 over 8. Just double check that for me, please.
No.
Minus 1 over 8.
7, 8. 7, 8.
Minus 1 over 8.
Yeah. Okay. X to the power, that would be 3 over 2. Negative 3 over 2.
Oh, you mean the whole thing? Okay. Not just the part.
Yeah. Right?
Okay.
Everybody's on one page. Everybody's on the same page. Right? Cool.
Okay.
Okay. Now we have what we need. Now let's do first principles. First principles, they want the gradient equal to the limits as h approaches 0 of f of x plus h minus of x all over h. Right. This will be the limit as h approaches 0 of f of x plus h is all of that. So it's x to the power half plus half x to the power minus half h minus 1 over 8 x to the power minus 3 over 2 h squared plus all the powers of h later on, then whatever goes, but we only need to show the first three, right? Minus x to the power half, because that's f of x, right? X to the power half all over h. Now it's gonna happen that and that is gonna cancel. You'll even see when you're doing, I'm sure it's something was patched that at your third line you should have only factors of h over h, right? So you're gonna end up with the limit as h approaches 0 of half x minus half h minus 1 over 8 x to the power minus 3 over 2 h squared plus whatever powers of h later on. You write this because it continues continuously until whatever factor that will bring it back to a constant, right? Now, if I introduce the limit of 0, I'm going to end up with 0 over 0. So I'm going to pull out a, right? And the common factor at the top is h, and then h will be able to get rid of the h in the bottom. So I'm going to end up with h into half x to the minus half, right? Minus 1 over 8 x to the power minus 3 over 2 h plus whatever other powers we carry out later and h, right? Cancel, you're left with the limit as h approaches 0 of half x to the power minus half minus 1 over 8 x to the power minus 3 over 2 h. Now I can, plus whatever other powers. Now I can introduce the limits as h approaches 0. So what's going to happen? You're going to end up with half x to the minus half minus 1 over 8 x to the minus 3 over 2 times 0 plus whatever powers later on. So what's going to happen?
All basically your h.
It's gonna
In the
cancel. So you're left with half x to the minus 1 over 2. You can also write it as 1 over 2x to the power half. Right? Now, before I carry on, right? Why we only take 3 factors is that, remember, if you evaluated, you carried on, you're going to end up with plus a term h cubed plus another term h to the 4. Now when you take out the factor, you're going to end up with h into this plus the next term, which will be h squared, plus the next term, which will be h cubed, carrying on, right? Forming factors. But you're going to substitute 0 for h in all of those. So all of those are going to be 0. So why we only show that first 3 is because we'll show at this point where it becomes 0, and then from there everything onwards will also be 0. So that first term is the only important one. Okay? So this is the formula for the gradient.
After substituting, you don't have to put the plus.
Because remember, after you substitute 0, you're also substituting 0 for everything. And all that is going to be 0. Okay? So you're just left with this. So, if x is equal to 4, the gradient will be equal to 1 over 2 times 4 to the power half. When you put that in your calculator, watch it.
One over 4.
1 over 4. So this will be the gradient of the tangent at x is equal to 4. Who's completely lost? Not bad. There's nothing to really check here, but it's just that a lot of
But those two, you use the M, and then when they're just asking you to do it.
when they want differential coefficient, you're gonna see for derivatives there's a whole lot of names the way you ask it. They can ask you for the derivative of y with respect to x, derivative, differential coefficient, all these sort of things, but you get used to it as you do more examples.
But it's all the same thing.
Right? So this was basically differentiation from first principles.
Okay.
Is anybody confused about what I did? No.
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 It's fine. How will you pretend? Not bad. Good. Not bad. Right? You want to do one more example? Can I take it?
Yeah.
Yeah.
First principles is not bad, but as long as you're whatever you're working out your brackets and stuff is. And if you see powers that are obviously long, like even x to the power 4 or something like that. In this case, x power. Yeah, say x to the power 4 onwards, used binomial theorem. And if you have x to the power of a fraction, you would use binomial theorem, right? For the x plus h part. Okay. What example can you? Okay, so you see they also give you an alternative method on the bottom of page 185, going on to 186, where you don't use it as x to the power half, you just take it as a square root. But that method is a bit confusing because you end up with a whole lot of third signs, and as you're going, you're gonna end up like mixing it up and stuff, and it can't be used for all of the types of questions you can get as compared to how your binomial theorem would be. Okay? So, okay, let's do one from exercise 620. Let's do that first one, right? X cubed. So, they say calculate the differential coefficients of the following from first principles. So, they want x cubed. Okay, so all you basically doing, your f of x would be equal to x cubed, right? And then your f of x plus h would be equal to x plus h cubed, which is x plus h, x plus h, x plus h, right? So you're going to end up with x plus h into x squared plus 2xh plus h squared. I just multiply these two brackets out. Okay? Then introduce this one. This would be x cubed plus 2x squared h plus xh squared. Right? Now I'm going to multiply the h into it. I'm going to end up with x squared h plus 2xh squared plus h cubed. Understand what I did?
Yeah.
Anybody confused? That FOIL method, right? Just multiply it out. Group any common or like terms. X cubed, that's the only term with it. 2x, any other terms but x squared h. Yeah, right? So that'll be plus 3x squared h. Any other terms got xh squared.
Yes.
Okay. And then you have
No, other way.
X.
X. I squared.
like that, right? Okay? We covered all our terms. We never forget any terms? I don't think so. Yeah, covered all our terms, right? Now we got f of x plus h, we got f of x, right? So now they want the differential coefficient. How does that symbol look? F prime x would be equal to, first principles, the limit as h approaches 0 of f of x plus h minus f of x all over h, right? This would be equal to the limit as h approaches 0 of, substitute, x cubed 3x squared h 3x h squared h cubed minus that term, right? So it will be minus x cubed all over h. Fine. Okay. This would be the look. Okay, so this and that would cancel.
out.
So you're left with the limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed all over h. Now if I had to take the limit at this point, I'm going to end up with 0 over 0. Because I would have substituted 0, 0, 0, I would have ended up with 0 over 0. Now limits in the form of that, we try to factorize to get rid of the factors that give us 0. So, take the limit as h approaches 0. To get rid of this h, I have to pull out h as a common factor. That should be 3x squared plus 3xh plus h squared all over h. Cancel, cancel. I'm left with the limit as h approaches 0 of 3x squared 3xh h squared. Okay? Now what you're going to end up with? 3x squared plus 3x times 0 plus 0 squared. So 0. 3x squared. Fine.
Yeah.
Okay. The method is not bad. It's okay. Do you want to do what?
No, not yet.
This is the same thing basically. Was that a little bit more difficult?
Which one am I looking
5.1.
at? Y is equal to ax squared plus bx plus c. Same. That's how
Same
we do
thing,
this. Yeah. And I do this one.
No, not the.
I don't have a 9 and
I don't know. It's more difficult, isn't it?
No,
Because-
it's the exact same thing.
Yeah. Just
Which
the
example we did? You know the example when we did like y is equal to 3x squared plus 2x,
Yeah.
right?
Yeah.
You'll just have one more term there where you'll have that one or the c factor, right?
Okay.
And only over here they never give you numbers, they gave you the
Letters.
letters, so that will try to confuse you.
Yeah.
Method is still the same. Multiply out the brackets. Okay, first principles, 5 marks. That's exactly like how we did this. Your f of x will be equal to that term. Substitute x plus h, you'll get another factor. Well, not a factor, another equation. Substitute into this formula. You cancel where you can. Good.
And have a 9 in the exercise? What is the other one?
I think it's a cube. 1 over 3. So the number 9 in the exercise is 1 over the cube root of x. So your f of x would be equal to x to the power minus 1 over 3. And you use that to solve. So you obviously have to use binomial theorem. So first principle, guys, are we okay? It takes some practice, but your understanding of it, you'll understand what we did, how we did it, right? It's not bad, right? But you need to practice it. Okay, so that was differentiation from first principle. How are you in time?
26.
Take a 5-minute breather. Okay. Let's take a 5-minute breather and we go see my other class too, and then okay. Right. Now I am on page 6.4. Well, we're finally into pure differentiation now, right? The heading even says it, differentiation introduction. But we were doing differentiation in but from first principles. Right, differentiation. So introduction. To calculate the differential coefficient by starting at x plus delta x and y plus delta y, or even using the formula as the limit of h approaches 0 and then the old formula, is very time consuming. Right? It is only logical to find a shorter method. If the differential coefficient of y is equal to sine x is formally proved, the result could obviously be used later. Because you just take it for that equation, you substitute it, so you just convert it, right? In practice, there are a number of standard differential coefficients and formula which can be proved, which are widely used. Symbols for differentiation. So, the symbol D or D over D means to differentiate. Right? When you add the x in the bottom, it means to differentiate with respect to x. If you add the y on the top, it means that you are differentiating y with respect to x. So you know when you're given a formula y is equal to x squared plus 1, right? And if I want dy over dx, I want you to differentiate that equation y with respect to x, meaning that the answer that you get after you differentiate should have factors with x. Do you understand what I'm saying? You see, when, just say you have x squared plus 1, right? And if I ask you for, okay, y is equal to dy over dx, I'm asking you to differentiate y with respect to x. Y is equal to that. I'm asking you to differentiate this with respect to the terms x. So your answer that you get would come out to 2x. That will be your answer if you differentiate it, right? You see, you differentiated the equation y with respect to x. So your answers that come out would have factors of x. You understand what I'm saying? Okay. So, there's more ways of saying it. They can sometimes tell you ds over dt, which means you're differentiating s to t with respect to t. So for anything, if you have dx to the power n over dx, so your top one, you're differentiating that over whatever's in the bottom, so with respect to whatever's in the bottom. Okay?
Essence is 1x.
It can be any factors.
There's nothing.
So like if I told you there, s is equal to t squared plus 1. Same thing, guys. If we just like to use x and y. If they told you a is equal to b, it's the same thing. You just obviously have a where x or a where y is and b where x is, right? Okay. If x is equal to, if y is equal to x and is given, then both sides of the equal to sign can be differentiated to x. So what they mean is, if you had y is equal to x and you add the differentiation symbols to both sides. So you introduce d over dx of y equal to d over dx of xn, right? So it's dy over dx is equal to d over dx, right? So what that means, you're differentiating y with respect to x, right? And here you're differentiating this equation with respect to x, and you're going to see this portion what it means when I introduce the rules. I'm just giving you the terms or the symbols that I use, so you'll need to remember. It's gonna get you there, right? The more we do it. So, the following notation is also found in textbooks y prime, which means differentiate. The right hand side will indicate the variable x. So if you have f of x is equal to x to the power n, right? The following notation will be accepted. So you will introduce derivatives on both sides of the bracket. Can you see that? D over dx f of x is equal to d over dx x to the power n. When you're writing d over dx of f of x, you can write it as f prime x. So it's the derivative of it, right? So it's the differential coefficient. Okay? That's okay. So that's just some symbol theory that you should know. Right? Now, this is the important thing. Standard differential coefficients and rules. Right? The following rules can be proved, and it has been proved. Right? So there are 15 rules. But no, you don't need to memorize it. You need to know how to use it, because that rules are given. You'll see only couple are not
on the table.
table. But you'll see couple are not given because it's very straightforward ones, like the constants and stuff. You won't see the one with the 0 and the 1, and I think even a couple others over there, right? Because some of them are straightforward. You'll see it in the application, right? So highlight that. That's very important. Okay, those rules, because you'll see at the top of page 189, these rules are as important to differentiation as 2 plus 2 is equal to 4 is to arithmetic. So it's very important, right? You can't differentiate without knowing these rules, or you're making differentiation very difficult, right? You must know them. We have proved some of these rules as an illustration. I don't think for the syllabus you are required to know the proof of any of these rules, but I'm more worried about how, I'm worried, I care more about how you use these rules, right? The application of these rules. So, I'm going to move on to application of differential rules at the bottom of page 191. When I do applications of these rules, you'll basically see what they did in those proving formulas, right? They basically, everything on page 189, 190 and the top of 191 is basically them proving some of the rules, some of those 15 rules. Okay? Fine. Right. Application of differentiation rules. Note that there are different ways of asking questions and the notations can also differ. Right? Now, let's get into it. Right. So they ask you, top of page 192. Differentiate x to the 6. X to the 6 with respect to x. So you're going to introduce your derivative sign or your differentiation symbols, right? So you're differentiating that with respect to x. You're differentiating x to the power 6 with respect to x. That's what that means. You're differentiating x to the power 6 with respect to x. Understand? Looking at this and going to your rules. Going to your rules. Right? Which one of the rules would you use here? The first one. What is the first rule?
d over dx x n is equal to mx to the power n minus 1.
That's the rule. Right? That's the same thing. N over here is what? 6. Right? So this would be equal to 6n to the power 6, 6x to the power 6 minus 1. Right? And what would this become? 6x to the power. So you differentiated that. Now think back to our other first principles questions.
Yeah.
Right? Like one of the questions we did was, what was it, tx squared plus 2. Right? We did it with first principles. If we you just had to differentiate this, I would have said d over dx of 3x squared plus d over dx of 2x. This would have been what? So it would have been 3 times 2 x to the power 2 minus 1. Right? Okay? Okay, let me write it differently, right? So you take out the 3, right? It would have been 3 d over dx x squared. Okay? I took out the constant. That there, taking out the constant is rule number 2. See, you have d over dx k x to the power n. You see how it's written after that? K outside d over dx xn. D over dx xn you would use rule 1. Understand? Right? Here I'll do the same thing. Plus 2 d over dx x. Okay? So this would have been 3 times 2x to the power 2 minus 1 using rule 1. Plus 2 times using rule 1, it would have came out to 1 x to the power 1 minus 1. X to the power 0 is 1. So it would have just came out with that. Agreed? 3 times 2 is 6. X, because 2 minus 1 is 1. Plus 2. Go back to our question with first principles. What answer we got? 6x plus 2. So that's a shorter method of using it.
So it's the same thing.
It's the exact same thing, but with one we used first principles to solve for it. And so how
But
they
you can see the
basically,
pattern developing when you're doing the examples for the first principle.
yeah, that's the method they use, right? They're using first principles and whatever other differentiation methods, they were able to solve for these 15 rules. But they said because using first principles is such a long method, they came up with these standard rules. So that's how you can double check your answer if they ask you a question on first principles. So far okay, I'm gonna do
Yeah.
a whole lot of examples with this differentiation, right? Because the only way you're gonna learn it if we do examples, right?
But if they ask you in a question, they will say using first principles.
Yeah.
They'll say,
So for first principles questions, like how that one you showed me, right?
They'll say,
They'll give you the equation and they'll say solve using first principles. You cannot use this method here because they will mark it wrong because you're not using first method. This is just differentiation. You just differentiate it. It's a shorter method, right? Okay. I'm taking this one like that. Let's do another example. So another example is calculate dy over dx if what question? 4 is y is equal to 4x to the power 10. So they want you to calculate the derivative of y with respect to x. So what would you do? Okay, write down your equation that's given first. You introduce d over dx to both sides. Okay? So when you introduce it, you're going to end up with d over dxy equal to d over dx 4x to the power 10. All I did was I introduced d over dx on both sides. This here will become dy over dx. Okay? Fine? Anybody confused about this? Fine. So we got it in the form that they wanted. To differentiate y with respect to x. Right? Looking at rule 2. Rule 2, you take the constant out. So this would become 4d over dx x to the power 10. So that is rule 2. Right? So now you left, okay, I'm just going to say equals to. Right? Now you're left with that. What does this do here? Which rule would you use to differentiate x to the power 10? Rule 1. Right? So using rule 1 to differentiate this, you're going to end up with 4 times what? 10
X.
Yes.
Okay? Can you understand what I did here? Okay? Because remember, look at this form and look at this. It's the same thing. And your end value is 10. So you'll end up with 10x, 10 minus 1. Okay? So for here we used rule 1. And now it's a straightforward equation because you just solve for it, right? So this would have been 40 x to the power 9. If they asked you for first principles, you would have used binomial theorem to solve for the whole thing. With the shorter method of just differentiating it using the rules. Get this. And do we all understand? Not bad.
So remember the rules.
Yeah, you don't remember, you have to know how to use the rules. Because the rules are given to you.
Where
The
is
rules,
where is it? Yeah.
the first one, I think.
NaX in minus 1.
Yeah, so what
You
that
use the second one and you got
no, not that.
the first one.
See, on your first one here, they say they have it like this, and they have dy over dx, right? So they're telling you if y is equal to a n to the power n. It's actually supposed to be ax to the power n. It's supposed to be ax to the power n, right? the derivative of it will be n times a x to the power n minus 1. What that means is that, just make a note of this, it's not supposed to be n, it's supposed to be x in the bottom. A, that's not me, that was the department. Before you'll say me, that was the department, right? So if you look at this example, right? Y is equal to 4x 10. Y is equal to ax n. Right? When you're writing the derivative of it, dy over dx would be equal to 10 times 4 x to the power 10 minus 1, which is 40 x to the, which is there. It's the same thing we did here, it's just that they wrote it down, they combined the constant and our rule 1 and rule 2, they wrote it as one. Can you see it? You can see it, right? It's actually rule 2.
It's rule 2.
It's rule 2. It's rule 2. That whole thing is rule 2. Because remember, rule 1 is in rule 2.
Yeah.
Are we all okay?
So the dy over dx is showing you
The derivative,
when you take the constant out, like rule 2.
like rule 2. Understand?
Yeah.
Getting there, getting there. Who's going to use that?
No, it's better to use this water.
No, I'm not going to debate. Yeah. What's my message to you?
Thank you.
Can I take out this?
Yeah.
Yeah.
Can you give another example?
Hmm?
Do another example?
Yeah.
Why don't you just use the whole thing?
No, I'll take out one piece.
You got a bunch already. Yeah, page.
So, example, calculate. Alright, now we get into the good stuff. Right. They want you to calculate f prime x if f of x is equal to 2e to the power x plus 1 over x plus 3 sine x. Let's get into it, right? So write down your equation first.
Find them below.
F of x is equal to 2e to the power x plus 1 over x plus 3 sine x. That was the equation given to us. Yes? Yes. Now introduce d over dx on both sides. Okay? So this would be d of d over x, f of x equal to d over dx to 2ex plus 1 over x plus sine x. Right? Now pretend that you're going to say yes, right?
Yes.
Right.
Yeah.
Now, go to the top of page 188. Top of page 188, just above your rules. You see, they told you over there, d over dx f of x. How they wrote it next?
F prime.
F prime x. So this here would become f prime x
Right.
equal to. Now you take the derivative of each term. So you take d over dx of 2e to the power x plus d over dx of 1 over x plus d over dx of 3 sine x. All with me, right? Equal to, you got a constant being multiplied by a function. Take your constant out, right? So this will be 2 d over dx e to the power x plus d over dx. I can write this as x to the power minus 1 plus, now the constant being multiplied by a function. You take your constant out. 3 d over dx sine x. Go to your rules now. Right?
That's rule number 1.
Right? Go to your rules. D over dx of e to the power x is what? Yeah?
Is that rule 5?
No, rule 1.
Sure. Follow your rules. Go to your rules. Which one looks like d over dx e to the power x? Right? Number 5, right? It's okay, it looks small, but it's d over dx e to the. I think you can also use your other sheet if you can't see it so clearly. Check it around it. Do you have anything in the e to the power x?
The E, no.
Oh, because okay, the reason why is because the derivative of e to the power x is e to the power x. Okay? That's why they don't show you the ones like number 3, 4, 5, because those things are like either equal to its own number, it's equal to 1, or it's equal to 0. Right? So the derivative of e to the power x is e to the power x plus d over dx x minus 1. Which rule does it look like?
Number 1. First one.
Rule number 1. Can we all see that? D over dx x to the power n. Your n is what? Minus 1. So this would now become minus 1 x to the power minus 1
Minus 1.
minus 1. With me?
Yeah.
Yes. Plus the constant d over dx sine of x is what?
Rule number 1.
Cos
X.
Cos x, right? So that's cos x. So let me write it. This rule here, we got it because of rule 5. This we got because of rule 1. This we got because of rule
9.
So your answer would be 2 e to the power x minus x to the power minus 2 plus 3 cos x. And you can write this as 2e to the power x minus 1 over x squared plus 3 cos x. And this answer here is f prime.
What's wrong with the gradient? That says x minus 2.
No, nothing wrong with it. I'm just saying you can
Try to fix it.
to make all the powers look positive. So. How are we feeling about it so far?
Yeah.
It's a baby steps though.
It's better.
Too bad.
Not too bad, right?
Is this one?
It's in baby steps.
Okay, no, the only thing that does, it's not difficult, right? It's just tricky, right? When you're going to start learning about the chain rule, the product rule, and the quotient rule, but even then, trust it's except formulas. You just need to know how to use the formulas, right? So you'll see, like if you look at one of the past paper that you did, they'll have one question where they'll tell you calculate the derivative of, and give you one more equation, like how they gave that, right? Basically means you must use your rules. You know, like how in trig they'll give you, they say simplify sine of minus x plus tan 180 plus x. Then you have to use all your rules and eventually you come out to a term, right? Same thing over here. You start your question like this. You will write down what they give you, right? The equation that they give you. Introduce the derivative d over dx on both sides, right? When you also remember, like look at it as whatever factor that they're giving you here. They want f prime x. They want you to calculate the derivative with respect to x. Yes? If you go back to symbols and the meanings, symbols and for differentiations on the bottom of 187. D over dx means what? Differentiating with respect to x. That is why I introduce d over dx to both sides, because they want me to differentiate with respect to x. If this said f prime s with respect to s, so I would have introduced d over ds on both sides. Okay, so that's fine. So I introduced d over dx on both sides of the equation. I did that looking from our earlier notes. The derivative of f of x over d of x, we can also write it as f prime x. Right? On this end here, now I've got a whole equation. I want to get the derivative. I get the derivative of each term. Okay? Using this here, so these rules here that I used was rule 2. The rule 2 was used to basically pull out the constants. Right? Rule 2 was used, I pull out the constants from each one, and now I have d over dx of e of x, d over dx of x minus 1, d over dx of sine of x. Going back to your rules, I used each rule to get these here. And then I just simplified it into a, well, I simplified it the most you can go. That's how I got it. Practice will make perfect on this one. Right? Let's do another example. Let's do what page? Can somebody help me? What page am I?
190.
190.
I feel like I taught 190 a long time ago.
That's
I'm on 192 at bottom. Okay, now I'm on 193. Right? Now we another example. Right? They ask you. You're with me, right?
Yes.
Anybody confused? Easier than 6 to see that.
Yeah.
Or they give you a formula.
Easier said.
Calculate dy over dx if y is equal to 4 prime x. Or they say, or put differently, differentiate y is equal to 4 prime x with respect to x, or calculate the first derivative. All of those things mean the same thing. Okay? They're just telling you different ways they can answer the question. Don't be confused. So they want dy over dx. How much want you to start the question? Write the equation that's given to you. Y is equal to 4 square root x. They're asking you to calculate the derivative of y with respect to x. So what would you introduce on both sides? D over dx. You understand that, right?
Yes.
Okay. So you introduce d over dx times y equal to d over dx for
Can I change?
Yeah.
Can I change the roots and say x to the power?
yeah, I'm gonna do it next time, right? So here d, so this would become what? D dy over dx, which is what they want. They want it in that form, is equal to, you pull out your constant. So this is 4 d over dx, x to the power half. Right? Because if you go to your roots, can you see anything that got a square root? No, right? But square root or root to something is 1 over the numbers that you are looking at. Right? So what you would do here now, d over dx, x to the power half looks like which rule? Rule number 1. X to the power n is equal to n x to the power n minus 1. So this would be 4 times half x to the power half minus 1. So this here is rule 1. Right? And then all you do is you just simplify your bracket now. So this would become 4 times half is 2 x to the power minus half, which is the same as saying 2 over x to the power, and you differentiated, you calculated dy over dx of y is equal to 4x for square root x. Are we all still together? Let's do another example. Right? Let's do
You need to keep it on this board because this writing is bad.
yeah, the body is dirty there. Okay, I'm taking on the side, right?
Yeah.
I'm losing time.
Too much. It's 11 o'clock already.
Level, right?
No, it's 20 plus
3 plus level.
10. 20 plus 10.
Differentiate x
What's
to
your Russian for structure?
take this.
Need to break the ice in this class.
Right. Differentiate x squared. No. Differentiate f of x is equal to x to the power 6 plus 3 minus 4x squared. Okay.
2x. Okay, so differentiate to x.
2x, right? So you're differentiating in terms of x. This is all the different ways that they could ask you to write this, right? So first thing, what should you do? Write down the equation.
Yeah.
F of x is equal to x to the power 6 plus 3 minus 4x squared. Right? They want you to differentiate it with respect to x. So what would you introduce on both sides? d over dx. So you end up with d over dx f of x equal to d over dx x to the power 6 plus 3 minus 4x squared. Right?
Why do that?
So
The
it's
last
fine.
one you did each one.
Each.
No, it's
Yeah,
fine.
no, I didn't do it. I wrote it like at first.
Yeah.
I introduced it first,
Next step.
then I multiplied it into each one. Right?
Oh.
Is it? Okay, I thought you
No, it's it. Yeah. It's it.
Okay?
You must have.
So, d over dx of f of x can be written as f prime x. Right? Now, I've got the d over dx of a lot of terms. I'm going to take the derivative of each term. So, it will be d over dx x to the power 6 plus d over dx 3 minus d over dx 4x squared. Okay, let me write this as 4x to the power minus 2. Okay. Right? So, you know, notice some sense. If you see any square roots, convert it to a power. If you see any fractions where x is in the denominator, convert that to a power. Right? Because you won't get any derivative rules like that. Right? Cool. Let's take out the constants first, right? Okay, now let's take out the constants, right? D over dx to the power x6, there's no constants there, right? Plus d over dx3 minus 4 d over dx x to the power minus 2. All I did was I took out the 4 from the one term. The 3 is a constant.
Yeah.
Right? You're gonna see now, right? That's only if you have
a rule, isn't it?
the rule 2 is a constant multiplied by a function. Then you take out the constant.
Yeah, you gotta
Or if you have a constant multiplied by, it was x to the power n.
So you took out the constant.
So
DC.
If the constant is being multiplied by a function
it's 0.
that has x, then you take out the constant. If it's just the constant, there's a rule for that, which you're gonna see now, right? Remember, it's different to the other ones we had, right? You understand what I'm saying?
Yeah.
Remember the other ones we had like 3x squared. It's the constant being multiplied by a function. So that's why we took it out. It's different from just 3. Because that's just a constant.
Oh.
This here is 3x to the power 1. Yes? Yes?
Yeah.
Right. What's going to happen? You're going to end up taking out, so,
It's real plus 0.
yeah, it's going to be x to the power 0, which is 1. And then you end up with 3. Right? If you look at rule,
Rule 3.
your constant becomes 0.
Yeah, because if
No, sorry, I lied.
no,
This is not x to the power 1,
it's
it's x to the power 0.
0.
Sorry, I lied. Because if it was x to the power 1, it's 3x.
Yeah.
That number is not 3x, it's 3. X to the power 0 is 1, 1 times 3. That's why we only have a constant. What's going to happen is you're going to end up with 3 times 0 x to the power 0 minus 1. 0. 0. So that's why the derivative of a constant is 0. Understand what I'm saying?
Yeah.
So, here, d over dx x to the power 6 is what?
So
6
6 rule 5.
Which rule? Rule?
1.
Rule 1.
Rule 1. Rule 1, right? This would be 6x to the power 6 minus 1. So this here is rule
1.
Rule 2, and then you put it.
d over dx of 3 is which rule?
0.
Rule 3, which is
0.
right? And in here would all be which rule?
1
One.
again.
Rule 1 again. So this would be minus 4 times
Minus 2.
minus 2 x to the power minus 2 minus
1.
1. With me, right? Right. This would be 6x to the power 5 minus or plus 8x to the power minus
3.
3, which is 6x to the power 5 plus 8 over x. Valid?
So you use rule 2 there also to get that equation. Move the constants out.
Yeah, well, rule 2 you always, when you see a constant multiplied by a function, then you would remove it.
Oh, yeah. It's rule 1, rule 5, rule 8.
What's
This thing of the application of these rules is 15 rules. I think I'm gonna remember all
So
those
all you
15
do, that's why I did it the way I did it, right? Because I came to this point here. Just go to the rules and see what looks like that. Whatever looks like that is your plan. I'm not asking you to memorize the rules. What I'm asking you is to look from your page to their page. You see the page? It looks like this. Cool. I'm gonna use the rule. And then you use it. Calculus is not difficult. It is difficult. It's tricky. Right? A little bit difficult. But it's tricky, but everything is given to you. Everything is there. You just need to choose it. They gave you all the ingredients. Cook the food.
Yeah. I'll take a photo and then, or you're gonna do another one on the side.
Take a photo. I'll do another one. Put big on this.
Oh, yeah.
And also, can you see the only way you're gonna get used to this is by doing examples. Because see, now we did how many examples? Like 4. Right? We did 4 examples. You're already used to rule 2. No, rule 1, 2. Like solid. You'll know when you'll see it, you'll already know what it is. Right? So the only way you're gonna understand, it's impossible for me to do every type of question where you can use every type of rule in it. Right? That's where you all need to go and do your application, use your rules. Okay? Now I'm still going to do another example, right? So I am now doing okay, let's do 194, top of 194.
Do the sign. Yes, one, yeah. Yes, one, yeah. That one.
Talk to me. Dean, why is it Dean? Yeah?
No, I'm scared. Do this one. 9.3.
Yeah, we can do it.
Yes?
We'll do it. Okay. Okay, let's do one, right? Okay. I got one from a past year paper. Yes, so I can take this out.
Yeah.
Baby mama. This one should use most though.
Let's see, I'm gonna figure it out as I'm going to. I'm just gonna speak for 1 over number whether I take it as the
It's a past paper on it.
okay, I'm just gonna check that you got all do 1 over there. You all can attempt it, don't you? Attempt it. Don't look at the solution.
No, phones. But
We got the solution with you. Got the solution with you.
no, but I got my phone. There.
Yeah, which paper? I just want to see how they do the cot X. I just want to see how they run over cot X and then. Okay.
X squared x.
Oh yeah.
Oh! Okay, and let's see this line now. You know what they did? You know what they did? They took 1 over, so cot X would be 1 over tan X,
Yeah.
which will come to minus 2 tan X. Okay. Okay, let's see the sign on and then I'll so that will be, yeah, that's fine. Posted articles, thanks. Posted articles.
Because it's squared.
Oh, hundreds. Right, let's do it. Okay. So, sorry about that. 101 gets long, so just getting it. Let's do it. So, they want you to work out the dy over dx of this whole equation. Right? So, that's your equation that was given to you. What do you need to do?
Right equation.
You know how you're gonna hate this one, you know why? Because you have to introduce some chick into it as well. So right. So introduce d over dx both sides. Right? So d over dx times y is equal to d over dx of minus 2 cot x plus 2 over root 3, no man, root x cubed, no man, minus 5 over sine x plus 4 to the minus 3x plus
1 over 7 ex.
right. Now,
X is at the top.
it's at the top, it is at the top, you are 100% right.
The right side is big.
Oh, geez.
Okay. Now, who said the rating? Okay, now we're going to use all our rules, right? Whatever rules we can use, we're using it. Okay? So, I don't know, simplify first and then okay, let's that, right? So this is dy over dx of d over dx minus 2 over cot x plus d over dx of 2 over, so
X.
this would be x cubed squared. No, 1 over.
No, 1 over.
Right? Because remember that, that minus 5 over sine x plus 4 to the power minus 3x plus, and this can be written as 1 over 7 e to the minus 3. No, man. You're not even telling me.
D dx.
Right? Straightforward. That is algebra. Okay. Do I have anything that has 1 over cot x in my roots?
No.
In your rules,
Yeah, wait,
There's no 1 over cos. It's just
no,
cot.
just cot.
you got cut it.
Not 1 over.
Nothing. Okay. Okay, before I do that, let's pull out constants first. Makes it easier when we're looking at what we have, right? So this is minus 2 d over dx 1 over cot x plus 2 d over dx 1 over. Okay, so x cubed to the half is what?
3 over 2.
Power to a power what you?
Add.
Power to power you add. Are we sure?
Multiply.
Multiply.
It's multiplied at 3 by 2.
3
half.
plus half.
Two. It's 3 over 2.
Power to power you add or multiply?
We multiply.
How many first you multiply?
Multiply.
How many first you add?
Wait a minute, say.
You try.
That's multiply. It's gonna be 3 over 2.
Multiply. Right? Okay. Then you'll have minus 5 d over dx. So what can this be written as?
My x minus
Minus 3, minus 2,
So
minus
this can also be written as x to the minus 3 over 2.
Yeah.
We all agree on this, right?
Yeah.
That's that. This is plus d over dx. I just need to see what this here will become. No? Quadrature constant.
Where's the sin x? It's 5 over sin x.
Where's the 5x? Temper.
How?
It's 1 over sin x.
I was quiet. I didn't say anything.
Right? E to the minus 3x. Now we got it in more friendly forms. Just that bit 4 to minus 3x. Let me just see something. To the minus 3x will become log minus
Hey. Yeah, sure.
right.
Yeah.
Okay. Now, yeah, that one of those one was confused with that one, right? So
would 1 over cot be 10x?
yes,
Yeah.
exactly, right? Because do we have the derivative of 1 over cot?
No.
No. But what is 1 over cot?
It's 10.
10, right? So this is minus 2, the derivative of 10x, x, 100, plus 2 d over dx. We know this one here because it's going to be what?
First,
This here, what is that? What does this look like? Which rule?
first.
Rule 1, right? So we know we can work that out, that's fine. Then we come to that just now. Here, 1 over sine is what?
Cosec. Or cosec x.
1 over sine is cosec x. Plus, so this form here, from your rules, look at your rules and tell me which one you think it will be. So now you have a number to the power minus 3x. Which one of those rules you think would be applicable?
15.
15. No.
Why you want to say
It's not x to the power.
So you change it to a log.
Yes, it's which rule is that?
6.
Rule number 6. So the derivative of that should be rule number. Say it with me, man. 6. Right? Rule number 6. So we know we can work this out, right? We don't need to simplify it further. This here is which rule?
Number 5.
Number 5 is
E to the power x, right? Which will be e to the power minus x, which is still it's gonna be like how you have d over dx e to the power x, it's equal to e to the power x. So that will be equal to e to the power minus 3x, right? So we know we have a rule for it, right? Yeah. Right?
Sure.
But I just want the same thing twice.
Yeah.
Yeah, I'm saying do I have a rule to work it out to derive it? Right? So I know whether to simplify further. See here, I didn't have a rule to derive it, right? So I simplified it to another form where I can have a rule to derive it. Understand what I'm saying? Right. Good. Equal to. Like I just flop one piece. And if I make the mistake, we'll come back and fix it, right? I never saw this question before. So it's like you both answering the exam, right?
Okay.
Cool. Right? Now, here, minus 2 times dy over dx of tan x, sec squared x. Cool. Here, you're going to end up with 2 times negative 3 over 2 x to the power minus 3 over 2 minus 1. Minus 5 d over dx of cosec x
Cosec x, cot x.
negative
Cosec x.
cosec x times
Cot x.
rule number
14.
14. Okay? Then this one here, we said we have to convert it into logs, which will be number 6. Rule number 6 is a to the power x is equal to a to the power x ln of a. Right? So it's going to be 4 to the power minus 3x ln of 4. Because your a value is 4 and your x term is minus 3x. Right? So this will be ln of 4 plus 1 over 7 e to the power minus 3x. Hey, that's fine. I need to do something there. But anyway, simplified, right? You're left with minus 2 sec squared x. And you're left with minus 3 x to the power, this would be minus 5 over 2 plus 5 cosec x times cot x, right? Plus ln of 4 does give you a number, but let's leave it like that, right? 4 minus 3x ln of 4 plus 1 over 7. Okay, let's write it as 1 over 7 e to the dx. And I think that is the solution. But I'm going to earn now to check if that is the solution. If the minus 2 sec squared x is right, the minus 3 to the power minus 5. How you can be 5 over 3? Minus 3 over 2 minus 1?
Minus 2 over 2 minus.
Because it's minus 1.5 minus 1, which is minus
2.5.
They probably made the number, right?
Minus 5 over
That's
2.
where it comes.
Right.
No, why do you have no sheets in front of you?
Open these cards.
Yeah. Wala ukufika uthina no khathala no khatha
So which one you got wrong?
Share your job.
The last two.
So the last two.
Because they got minus 3 times 4 minus 3x times. I don't know, that does make sense. The last one got minus 3 e to minus 3x times ln of e.
You know when they change it to log and they use rule number 7.
Try.
Okay. That 4 minus 3x.
Okay, but more or less, I'll go on my work paper.
Oh, this is what we didn't get kicked it in.
Yeah, no, but this is a very when you said this paper was
2021.
2021. This is a very, this one will obviously incorporate, and also I still never finish with what I'm teaching, right? You'll see there's still, see that 15 they showed you there. But if you go to page 211. There, 211. Look at how many rules they got in the summary of differentiation rules.
17.
Yeah, tell the page.
25.
Yeah. So we're not done, right? So obviously this year I'll start answering questions like this in the past year paper 10. But more or less, you'll understand the concept of how we're answering these questions, right? How you break it down. Okay. Can I go back and do what I was doing, right? Okay.
Do I take?
But more or less, this one here, I'll figure out this one here because that one and that one.
Do I take a photo or don't take a photo?
No, I don't take a photo. Right? Yeah, but I'll check that one out and tell you exactly.
How many marks is in lab?
How many marks are there? 5.
5.
One question. 5.
The shitty thing about the memo, they don't give you a lesson, they just give you the.
Answer.
But yeah, I'll do it when next time I'll check it out. Where was I now? How's it now? Give me 10.
Told you. The 11 o'clock.
See what 10. I stopped at, I did x to the 6 plus 3 minus 4 over x cubed, right?
Yeah.
Right. Now I'm doing. Okay, I'm not gonna do y is equal to square root of 2x because it's like how I did y is equal to 4 square root of x. Right? Yeah, I'll do the okay, let's do the other two, right? So they ask you to calculate. Yeah? They want dy over dx if y is equal to x squared plus 3x over x squared plus sine x over cos x. Right? Let's do it, right? Write down your equation. Y is equal to x squared plus 3x all over x squared plus then, right? So what you do, they want the derivative of y with respect to x. So you introduce d over dx, both sides, right? So it will be d over dx, y is equal to d over dx to x squared plus 3x all over x squared plus sine x all over cos x, right? Okay, so dy over dx is equal to d over dx x squared plus 3x all over x squared plus d over dx sine x cos x. Right? So, how are we going to do this? Right? See d over dx, this equation, can I not write it as x squared over x squared plus 3x over x squared? Right? I just broke it up. Okay. Plus d over dx. What is sine over cos? 10. Okay. Now what's going to happen here? Cancel, cancel. Right? You're left with d over dx into 1 plus 3x over x squared is what?
3 over x
3 over x, which is 3x to the.
minus 1.
Minus 1.
Everybody understands that? Okay. Plus d over dx 10 of x. So this is d over dx of 1 plus d over dx of 3x minus 1. Okay, I'm going to pull out the 3, right? X minus 1 plus d over dx of 10 of x. Right? And understand how I got you? Anybody confused?
Yeah,
You're okay?
Look at the 10x to 1.
No, I'm going to change it now. I still got derivatives earlier. I'm going to change all of it, right? So this is the derivative of a constant 0 plus this would be 3 times minus 1x to the power minus 1 minus 1 plus derivative of tan x,
6 squared.
which is equal to minus 3 x to the power minus 2 plus sec squared x, which is minus 3 over x squared and we build up to the questions like what Earl showed us. You get there. Easy trees. Right?
But you're going to jump around sometimes with the rules and that's such a key concept.
Yeah, because
everything that you learn.
they're never going to ask you a question where you use rule 1, rule 2, rule 3, rule 4 in order. They're going to make you go rule 1, rule 9, rule 15, rule 4, rule 8, 7, answer. Right? They're not going to make it that easy for you. But when I'm teaching you, obviously I'm going to ease you all into it. You're going to see how each rule is being played. So far, guys, from everything I did in the morning, from differentiation, from first principles, do we understand?
Yeah.
Do we understand differentiation using the rules? Not bad, right? Okay.
You do another example of that.
I'm doing another example. Okay.
But you can see it's slowly getting slightly more difficult as
Because it's not difficult, it's just they're adding more terms. Now, when you're adding the more terms, it's coming longer and it's looking difficult. But it's you see, when you looked at that, you think, oh my god, but when you actually look to each step, you don't know how to do it, the rules are there. Right? All the questions are the same. I want to do the log question. Okay, so what's the question? Calculate dy over dx if y is equal to log 4 x plus 2 log 5 x. Right.
Is that on the top? X plus
Hey,
2.
don't be so dramatic. It's right. It's 2 log base 5 x. Right. Now, who can tell me how you do this?
Well, you got some rules for logs, yeah? It's not by writing an equation.
Right. What you would start off by doing is converting these logs to natural logarithms. Remember I told you natural logarithms is ln. Okay, so what you'll do, you convert log to ln. And remember ln is, remember right there, this here is log of e to a number. Right? Okay? Very good. How do you convert it? Use the step. Okay, write it there, right? So don't confuse it with the answer. And the formula you use to calculate it is log a of x is equal to ln of x all over ln of a. With me? No, this is this is rules for logarithms. Right? So when you do logs,
Oh, it's there.
it's there somewhere, right? So what you have to do, you have to convert it into natural logarithms, right? So using this, your y formula would become what? Your a term in that first one is your a term here is 4, right? So that would become ln of x all over ln of
A. 4.
right? Plus 2 ln of x ln of 5. This is a value which you will obtain from your calculator.
Log ln4 from ln5.
But it will be 1 over that. Your calculator has a log button, I mean an ln button, or you could say log of e to 4. So you know where ln button is, right?
1.386.
Let's see what you did, your time there. 1 over. Remember, this is in the denominator. The value is 1 over ln of 4, and then you have ln of x. So that's how I get ln of x over ln of 4. Understand what I'm saying?
Give me
Negative.
0.721.
How are you getting negative?
0.721.
Yeah, it's
0.7
equal to 0.721
721.
ln of x. Are with me? Right? So 1 over ln of 4 is 0.721, and obviously it's being multiplied by ln of x. Right?
Okay.
2 over ln of 5,
It's 3.28. 3.219.
3.219.
1.243.
It's 2 over, not 1 over.
Oh, shit.
Something I don't remember listens to it this week, right?
Divided by
Right. Now these are both the same term, so you can just add these values up, right? So this would be 0.721 plus 1.243.
1.964.
Now that's the equation we will differentiate, right? So that's why,
Oh my
why,
god.
right?
Now
That's-
it's plotting.
Only if they give a log 1 with that. Okay? So you would say, so now that's the equation. What you introduce? D over dx, because you're differentiating y with respect to x. So dy, okay, so d over dx y is equal to d over dx into 1,964 ln of x. Okay, so it's dy over dx, your constant you would take it out. D over dx ln of x. The derivative of ln of x is what you.
Rule 6.
7. Right? Rule number 7, which is
1 over
ln of x is 1 over x. So it's going to be 1.964 times 1 over x, which is 1,964.
x minus
I said x minus, I heard you.
I wanted to put that x on top.
But they give you 1 with the log here and minus 1. Log 1.
Which log?
That's different.
Hmm?
If I see 194 x
Oh,
minus
x
It's
1.
only log 10.
Yes.
Yeah, is that log 10?
Yeah, so this is only log 10 when you're log
Log
10
10.
you use that.
Okay, so we've done examples where we used rule 1, right? We've done examples where we used rule 2. Rule 3,
Yes.
rule 4 we incorporated somewhere, then rule 5 we've done that. We've done ones, okay, in that one earlier that I showed you where you'll have to use rule 6, right? We've done one now where we use rule 7. Rule 8 is the same theory as rule, what do you want? Same application as rule 7. Rule 9, 10, 11, 12, 13, 14, it's your costs, your sine, costs and tan rules, right? We've used some of it. So you're used all the rules at some point now, right? So you all need to get good at using it. Okay? We've done a lot of examples on this. The only thing you all can do is more examples.
So, the one with the sine plus it follows the same rules as between angles and stuff.
like in terms of the identity,
Yeah.
like 1 over sine is cosecant. Yeah, that's trig. Trig will always be trig. It's just the derivative of it
Yeah.
would be different. So the derivative of, like how the derivative,
Like here that but sine is equal to cos.
yeah, the derivative of sine
Yeah.
is equal to cos. So if I have d over dx
Yeah.
of sine, the
Okay.
derivative of sine with respect to x
Yeah.
is equal to cos of x. Okay, like you know how in like in co-ratios we had rules. If I have 90 plus,
Yeah.
it goes to another term. Like, or if I have 90 plus, cot 90 plus,
Mm.
even to 10 or something, or negative 10, similar things like this. This is your derivative rules. Okay, guys. Okay, let's read at the end of page 196, right? There are a few examples there, you all can do that one, right? Because we've covered a lot of examples, right? Just before exercise 6.4, they tell you exercises in differentiation are usually just practice without practical application, right? Just above exercise 6.4. Exercises in differentiation are usually just practice without any practical application. Exercises involving practical applications are possible, but are more difficult to formulate. What they mean is, you may be wondering, what would we use this for? Like, why are we doing this calculation and stuff? It's used for graphs and analysis, and when you work your even when you're working on the gradients of a circle with building material and stuff. But to formulate questions like that, you're going to end up getting like science questions. Right? So they rather just give you practice examples that you can answer, and obviously that same application would apply to when you're answering a practical question in industry or whatever. Okay? So this textbook got a whole lot of examples. Past year papers got a whole lot of questions. Past year paper even got memos too, you can also use if you get stuck. Right? So, is there any questions so far? On anything I covered today? Anything I covered yesterday? Okay, so in terms of module 6, we've covered what are the concept of a limit, theorems of limits, application of limits. Right? We covered the binomial theorem. Today we covered differentiation by first principles. Right? We've used the binomial theorem in differentiation of first principles. We've done differentiation using the rules. Okay? We've covered a lot. Still got a bit more to go. So tomorrow I'm going to do, not tomorrow I'm doing revision. Thursday I'm doing the chain rule, and then I'm going to do product rule, so much longer. Then I'm going to do product rule, then I'm going to do quotient rule, and then I need to do graphs. Remember in for cubic functions, they said refer to module 6 somewhere in module 6. We use cubic functions, we solve for cubic functions using derivatives. Right? Yeah. Okay. So any questions? We're fine. We're getting there. We're getting there. Yeah, no, we do. But you see, like today, see after we do chain rule we've got a whole lot of examples. Right? Once you understand chain rule and I do a few examples, you'll be able to answer all the examples later on. Right? Same thing with product rule quotient. Once you finish those things, the graph questions will take about maybe a day to do. So we're gonna get this done one way or the other. Yeah. So tomorrow, please ensure you're like here. Why I'm saying it like I'm saying bye, sure. I'm here for science just now. Right? But anyway, tomorrow, please ensure that you're like here, because tomorrow is your revision for your test 2. Okay? Once again, is there any question on anything covered today?
So, after that we have integration. Integration that long?
I'm not sure. Right? Cool. So far, calculus, how's it?
Yeah.
Not as bad as we thought.
Not as bad as you thought, right?